Okay, today we are going to be doing 3.3 measures of central tendencies. So, most of you guys have heard of these. You just might not have heard them called that. But measures of central tendencies are mean, median, mode, and range. So we're just going to go quickly over what each of those mean. Okay, so mean is another word for that is average. Okay, do you remember how to take the average of something? Remember, you add up the numbers and divide by the total. So, by the total number. Add up data, and then you divide by the number of data. So if there's 5 numbers, you divide by 5. Okay, median, remember, think like the median of a road, the middle of a road. It's the number that's in the middle. When put in order, when numbers are in order, the middle number is, and I'll do an example of these, the middle number is the median. It's in the middle. Now sometimes there might be 2 numbers in the middle. Then you take what's in the middle of those. So if 5 and 6 are in the middle, it would be 5.5. You actually take the mean of those 2 numbers. Okay? The mode is the most frequent. So you could have you could have no mode, 1 mode, or many modes. You could have 5 modes. And you actually, okay, hold on. Okay, so, sorry, I got a phone call there, so hopefully this will just pick right back up. So, the next is range. So with range, the range is you just take the biggest number in the data list and the smallest number and you subtract them. Okay, so the difference between the biggest and smallest number in the data. And again, we'll do an example here in a minute. Okay, which I think you've all done this before. Okay. So find the mean, median, mode, and range of the data given. Let me change my color here. So mean, remember, is the average. So do you remember how to do average? You just add the numbers up and divide by how many there are. So 2 plus 5 plus 5 plus 3 plus 3 plus 4 plus 4 plus 6. And we're going to divide it all by 1, 2, 3, 4, 5, 6, 7, 8. We're going to divide it all by 8. Okay, so 2 plus 5 plus 5 plus 3 plus 3 plus 4 plus 4 plus 6. When I look at my little cheat sheet, that's 32, I think. 10, 14, okay, 32 divided by 8. So the average or the mean of these numbers is 4. There you go. I don't know why they use mean instead of average. I actually have an example for you that I'll probably bring to class that shows you somewhere where they used mean, and so I'm glad I knew what it meant when I was doing some research. So the median, the key to median is that you put the numbers in order from smallest to largest. So 2, 3, 3, 4, 4, 5, 5, and 6. Okay? Now, when you do this, you need to count, you need to find the middle. So if we mark these end ones out, mark this out, there's 2, here's 3. Okay, so we really have 2 in the middle here. They're both 4s though, so the average of 4 and 4 would just be 4. So the median is also 4. Okay, if there was another number in here, so if there was an odd amount of numbers, then you would just take that middle number. Okay. Mode is the most frequent. So when we look at this, there's 2 3s, 2 4s, and 2 5s. And there's just 1 2 and 1 6. So your mode is 3, 4, and 5. All 3 of those. Okay, range, remember, is the biggest number minus the smallest. So it would just be 6 minus 2, which is 4. When you do these, as long as there's not an outlier, which we'll talk about in a minute, your numbers should be fairly close. They're not always going to be 4, 4, and 4, but they should be fairly close to each other. Okay? Okay, so an outlier. An outlier affects the mean, okay? Which an outlier is a number much bigger, and yes, you have to write this, or smaller than the rest of the data. So, and the data that we just had, let's throw the number 20 in there. Well, which I think we're going to do on the next page. Then that is an outlier because it is way bigger than the rest of the numbers. So any numbers in an outlier is going to throw your mean off. So what an outlier is going to affect most is the mean or the average. It's going to throw that average off. Okay? So let's look here. So it says, how does 20 affect the mean of the data from before? So we had all these numbers that were fairly close together. Okay, even if you had like 15 or even maybe even 10 as this number, that would be considered an outlier. So first we might say, what is the outlier? So you would say 20, and then it says, how does this affect it? So that means you have to find the mean twice. Okay, so we found the mean the first time. Our first mean was 4. Okay, that was without the outlier. Without outlier. So to find it with the outlier, we have to add it all up again. Okay, so we have to add 2 plus 3 plus 3 plus 4 plus 4, whoops, plus 5 plus, whoops, I did not mean to do that, plus 6 plus 20. Okay, and then we're going to divide it all by 9 this time. So when I look at my little cheat sheet, now I can't remember what our other number was. It was 32, so 32 plus 20, 52. I have 50 down, but it should be 52 divided by 9, okay, which I totally have the wrong number. So 52 divided by 9, which would be, 9 goes into 52 how many times? Oh my gosh. 9 goes into 52. 9 and 6 is 54. So 9 and 5 is 45. So we subtract 12, 11, 10, 9, 8, 7. Bring down a 0. You'll need to do it at least to 1 decimal place. So 9 goes into 70. 9 and 7 is 63. Okay, so 5.7. We'll just round it there. Okay, so we'll say it's about 5.7. So the original question was, how does 20 affect the mean of the data from before? Well, it affects it. Let me change my color here. Okay, so the mean of our first one without the outlier was 4. The mean with the outlier is 5.7. So how does 20 affect the mean? You would do 5.7 minus 4. Okay, you find the difference. And remember, you got to line up your decimals when you subtract decimals. So this would be 7. So it'd be 1. So it's going to affect, the mean affects it. It goes up by 1.7. So this, when you're dealing with outliers, that's for sure your longest problems. They're still not really difficult, they're just kind of long. Okay, one more page. Okay, best measure of central tendency. So sometimes we'll just ask, what central tendency should you use? And some good rules for that, I'll tell you some good rules. Mode is best when you're not using numbers, so not numerical. Sometimes it doesn't matter. Like on that the first problem we did, that set of data, all the answers were basically 4, so it wouldn't matter. Okay, you could pick any of them, but not numerical. So if we ask favorite movies of 7th graders, okay, it's hard to take the average of something that's not a number. So that's why you would do the mode, okay? And remember, mode is the thing that's most frequent. So you would say the favorite movie is the movie that the most 7th graders said, okay? So median would be if there's outliers, then you would use median because you kind of find the number that's in the middle, because there might be an outlier that throws the mean way off. So you would need to use the median. And an example of that would be the distance people live from school. Distance students live from school. So you might have someone that lives, way out in Bixby, where the majority of you all might live in Midtown or in West Tulsa or whatever. This would kind of help with those outliers. You would find the one that's in the middle and go with that. Mean is if there's no outliers, because remember, outliers really affects the mean, the average. So whenever there's no outliers, that's when you would do the mean. So maybe the average temperature or the average age, that might even be better. Average age of 7th graders, because most 7th graders are around the same age. There's not normally a lot of outliers, depending on, I guess, what school you're at, but there's not normally a lot of outliers there. Okay, so those are some examples.